Okay, today we'll be looking at section 1.3, collecting sample data. Some of the key concepts here that the method used to collect sample data influences the quality of the statistical analysis. So it's really important that we collect our sample data in a way that's not going to create a bias and that can allow us to do quality statistical analysis. And one particularly important way to gather our sample is as a simple random sample that we'll talk about later. And I really love this last statement. If sample data are not collected in an appropriate way, the data may be so utterly useless that no amount of statistical torturing can salvage them. So in other words, we can take everything that we learn in this course, and if we haven't gathered our sample data in an appropriate manner, then we cannot salvage it. We can't take it and draw any kind of correct conclusion from it if we haven't gathered our data correctly. So today's lesson is going to focus on finding ways to gather the data in a way that is representative of the population. Okay, we talk a lot about the placebo and treatment groups and what we call the gold standard. And the gold standard is basically when we randomize the placement between a placebo group and a treatment group. And the placebo might be something like a sugar pill where it has no medicinal effect with it, but basically one group's going to be receiving a treatment, another group will not be receiving the treatment. They may be getting the sugar pill or whatever. That's kind of our gold standard for setting up these experiments as we go forward. So we have, when we look at collecting data, some of our studies are going to be observational, others will be experimental. So we need to know the difference between these. Experimental is simply when we're applying some kind of treatment and then proceeding to observe its effect on the individuals. Okay, so maybe we keep looking for treatments for this COVID-19 that we're all dealing with. So obviously, if we set up some type of experiment where we apply some type of treatment to see if it works and keeps people from either getting COVID-19 or getting better with it a little bit quicker, those are the type of things that would be experimental. Observational studies, you don't really attempt to modify the individual in any way. So you just observe and measure some type of specific characteristic with that. So we see the experimental ones a lot of times when we're having medical studies and so forth. Observational may be a little bit more with social issues and things of that nature. Okay, so here are a couple examples. We've got the first one in a clinical trial of the cholesterol drug Lipitor. 188 subjects were given 20 milligram doses of the drug, and 3.7% of them experienced nausea. So in this particular example, they are having a treatment applied, that treatment being the drug Lipitor, and so it would be an experimental study that was conducted. In the second example, in a trial, 100 subjects were given the new COVID-19 vaccine. The other 100 were given a placebo. So we see that placebo and treatment group here, and this would definitely be another experimental study. And the last one, in a study sponsored by Coca-Cola, 12,500 people were asked what contributes most to their happiness, and 77% of the respondents said that it was their family or partner. So there's no treatment being applied here, and therefore that one would be observational. Okay, on this example, we want to kind of look at the correlation between ice cream and drownings and see which would be a better study, an observational or an experimental study here. So in our observational study, we're going to observe past data and we see that ice cream, or we may think that ice cream causes drownings, okay, because we see that as ice cream sales increase, as the number of drownings increase. So when we look at that in a purely observational sense is going to cause us to miss a lurking variable, that being temperature or weather, that's going to actually cause both of these to be happening simultaneously. So as the temperature goes up, there's going to be more ice cream that's being sold, but there's also more people swimming and therefore more drownings because of that. So there's that lurking third variable that's going to be affecting this. It's really not going to show up if you try to conduct this as a purely observational study. If we look at it in the form of an experiment, we could conduct an experiment where we would take one group and treat them with ice cream and another group with no ice cream, and then we could see the rate of drowning for each of those groups. obviously we would see that there's no effect on that, no effect on the drownings based on whether they had ice cream or they didn't have ice cream. And so we make a better conclusion from that as an experimental study than as an observational study. Okay. Some some key components that we need to keep in mind when we talk about design of experiments. Replication is one. We mentioned this back with the autism study in a previous section, but replication is the repetition of experiment on more than one individual. So basically, you want to be able to take the take the study and repeat it and make sure that we're going to get similar effects from that on large enough samples so that we can see that it is a true effect that we're experiencing there. Blinding is a technique in which the subject doesn't know whether he or she's receiving a treatment or a placebo. It's really important because sometimes if you think you're getting the treatment, you may have a psychological effect from that, and it's just better for the person that's receiving it or not receiving it really not know whether they're getting the treatment or not. So blinding is a way to get around that placebo effect, which is what I was just describing, and that occurs when an untreated subject reports an improvement in symptoms. So maybe they're getting the sugar pill and because they have that psychological effect, and it actually causes them to see an improvement in their symptoms when in fact they're not really even getting anything that's going to affect that particular condition. You can have it to be double blind. Double blind means it's blind on two levels. Both the person receiving the treatment doesn't know if they're getting the treatment or the placebo, and the experimenter, the one that's applying the treatment, doesn't know whether they're administering the treatment or the placebo. Obviously, somebody's going to be keeping track of who's in the treatment group and who's in the placebo group, but the experimenter themselves don't know. And that's partly because you don't want to in any way influence it. Maybe just in the way that you administer something, maybe it gives it away that it's the treatment and then others the placebo. So you don't want to introduce any kind of bias in that way as well. Randomization is very important. It's when subjects are assigned to different groups through a process of random selection. So basically, if we randomly assign subjects to the two groups, our hope would be that they would be fairly equal groups and that they would be similar in the ways that are going to matter for us in a particular study. Okay, a simple random sample is kind of the gold standard, so to speak, for sampling, and we abbreviate that as an SR. It should be SRS here, but when you talk about a random sample, our definition is, or a simple random sample, our definition is a sample of n subjects is selected in such a way that every possible sample of the same size n has the same chance of being chosen. So when we talk about this and a simple random sample, a lot of times we talk about random samples, and a random sample would just be like if we reach into a bag of marbles and we pick out one marble, every marble in the bag has the same chance of being selected. So we're doing a random sample. With a simple random sample, it's a little bit stronger definition in that instead of selecting just one marble, we're going to select samples of a given size. Maybe we're going to pick out groups of 5 marbles, and every group of 5 has to have the same chance of being selected as every other group of 5. And that would be a simple random sample. We're not going to spend a lot of time differentiating here, but just know that a simple random sample is a stronger standard to uphold than just a random sample is. Okay. So, and that's kind of written here. A simple random sample is often called a random sample, but strictly speaking, a random sample has a weaker requirement that all members of the population have the same chance of being selected. Another type of sampling besides random and simple random sampling is systematic sampling. So with systematic sampling, we're going to select every kth element in the population. So like a lot of times on assembly lines where you're checking for quality control, they're going to take every maybe 10th or 50th item off an assembly line and check that to make sure it's holding up to the quality that they expect. So anytime you're taking any kth element of the population, then that's called systematic sampling. Your starting point should be random as well, so you shouldn't necessarily start with car number 1. It should in some way, you should randomly select the one that you're going to start with and then select every kth one after that. Convenient sampling A lot of people confuse convenient sampling and random sampling. Like convenient sampling is when the data is very easy to get. And a lot of people will think if they like stand out on a sidewalk and get people that come by to give their opinion on a survey that that's random sampling because they're like randomly picking people that walk by. But that's a convenient sample because that data is very easy to get. A true random sample is actually fairly difficult to get because you need to use random number generators and so forth to make sure that you're actually getting a good cross section and not just, for instance, in that example, not just the people that walk past you that day. It would be like everybody on campus or everybody in the mall or wherever you're at that would be participating if it in a but with convenient sampling it's just those that are very easy for you to have access to, like for instance in my class, if we were in a seated class face to face, then the people in my class might be an easy group for me to study and sample. Okay, stratified sampling. This is where we subdivide the population into at least two different subgroups, which are also called strata, and the subjects within those subgroups share the same characteristics. So, for instance, one subgroup might be gender, so male and female. You might divide a subgroup by religious preference, and you might have what like within this class we have freshmen, sophomore, juniors, and seniors. So that could be a subgroup, the subgroups that we're dividing our sample into. So typically with stratified sampling, they're not physically separated. It's more of a given characteristic that your population has that kind of divides it out. So maybe even by major, like business majors, education majors, and so forth, could be different strata within a sample. So with stratified sampling, we subdivide our population into these subgroups, and then we'll go in and randomly pick a few from each subgroup. So here you can see the two subgroups or strata are males and females. And then within each of those subgroups, we're going to randomly pick a few. In this case, we're picking three, and we'll randomly pick three over here. So that would be stratified sampling. An example of this would be like if Dr. Brown wanted to survey people's opinions about this virtual instruction that we're having here. Maybe he wants to make sure that freshmen, sophomore, juniors, seniors, and graduate students are all represented. Then he might go in and randomly select, say, 25 students from each of those subgroups to participate in the sample that he's in the survey that he's going to be doing. So here's a couple other examples of stratified sampling, randomly selecting 25 students from each grade level in a high school to survey their opinions about some matter that's of interest. Example number 2, randomly selecting approximately 5% of students in each major to survey their opinions. So if we wanted to survey all the students at Wingate and we wanted to make sure that every major was represented, then stratified sampling would be a good way to do that. Number 3, randomly select 100 males and 100 females from Wingate undergraduate to participate in a study. Because even though it's very unlikely, in a true simple random sample, there is the chance that our entire study would be made up of all males or predominantly males. So if you really want to make sure that certain subgroups are represented, stratified sampling is the way to do that. Okay, cluster sampling is one. Cluster and stratified are the two that people have the most trouble differentiating between. With cluster sampling, it's a little bit more of physically being grouped together, whereas with stratified sampling, maybe everybody's together, but the characteristic might be males versus females. With cluster sampling, it might be like schools, apartments, hospitals, prisons, those type things where the people are physically clustered together into sections. So we'll divide our population into sections or clusters and then randomly select some of those clusters and then choose all the members from the selected clusters. So here we're looking at different apartment buildings in an area. So if we're going to do cluster sampling, rather than having to physically go to all the apartments in an area here, it's a little bit easier logistically and therefore financially to do a cluster sample where we randomly pick a few of these apartments, we go into the apartment and then study everybody that lives within these apartments. Okay, so this is important here that we choose all members from the selected cluster. All right, so here's a couple examples. One, randomly choose 10 New York City apartment buildings and then survey every resident in the building for their opinion on housing. Number 2, randomly choose 5 schools in the county and then survey every parent with students at those schools concerning their opinion about issues related to the school system. Number 3, randomly choose 10 dorms at a major university and then survey all students living in those dorms concerning campus housing. Or randomly choose 25 prisons in the U.S. and survey all prisoners concerning prison conditions. So the key there is that once you've selected the cluster, you're going to go in and study every one of the people living there. So all are going to be represented. Okay, so here are a couple examples. Pause the video, take a minute to decide whether you think these are random, systematic, convenience, or stratified or cluster, and then unpause it and see what your answers should be. Okay, on this first one here, it's referencing every 5th driver, so this one should be systematic. The next one, you're selecting prisoners, so they randomly select 5 federal prisons and then survey all the prisoners from each, so that would be cluster. Number 3, a professor surveyed all of his students, so that would be convenience. And in a study of college programs, 200 students were randomly selected from those majoring in communications, 350 from those majoring in business, and 175 from those majoring in education. That would be a stratified sample because each subgroup is represented. Okay, here's 4 more to try. Okay, and the first one, that would be a random sample because the people being contacted were randomly selected by the computer, and so that would be a random sample. Number 6, we've got every 100th electrical component pulled off the assembly line, so that would be systematic. 7, we're talking about apartment dwellers, and 10 are randomly selected, and then each resident is surveyed, so that would be cluster sampling. And then number 8, the principal selects 20 students from 9th, 10th, 11th, and 12th grades. So that would be stratified sampling. Okay, so just a couple things about random number generators. Your calculator has a random number generator built into it. What this does is it basically tells you which people to choose to participate in your study. So in this case, if we were to gather a simple random sample of 20 students out of the Wingate student body, if each one was assigned a number between 1 and 3,400, then we could use our calculator to generate the numbers, and then we would go and find those people that correspond to those numbers. So to put this in your calculator, if you go to press the math button on your calculator and go over to probability, you'll see random integer. Press that and it'll bring up these prompts here. So you'll have lower of 1. You want to, there's about 3,400 students at Wingate, so we'll put that as our upper. We want to choose 20 students out of that for this particular example, and then press paste. If you don't have these prompts and maybe have an older calculator, then you'll still choose random integer, but you'll have to type it in like this, put 1 comma 3,400 comma 20. Press enter, and you'll see this list of numbers. You can use your arrow key to scroll across until you see all of them. But basically what we would do is we would go find person number 2,714 on our list of people at Wingate, and that person would be asked to participate in the study. And then we would find person number 3,237 and so forth. So each one of these would represent a person that would be contacted to participate in the study. Okay, types of observational studies. We mentioned earlier what an observational study is. There's 3 different types. There's a cross-sectional study, which I consider that to be the present. Okay, your data are observed, measured, and collected at one point in time. It doesn't span a period of time. This might be like people's pulse rates while they're sitting in class, or their blood pressure readings, or their weight. It could be any of those type things, but it's like just a very quick little snapshot of what's happening at a given time. Retrospective, which is also called case control study, is the data is collected from a past time period by going back in time. So if you think retro means back. So you go back and look at records and interviews in order to figure out what might have happened. For those of you that are local to the Charlotte area, Huntersville has a cluster of eye cancers. It's a very rare eye cancer that there's a cluster of in Huntersville. So what they've done with that is they have done a retrospective study where they take those people that have the eye cancers and they're going back and looking at environmental, did they go to the same high schools? Did they drink the same water? Those type of things. But they're going back in time from that particular moment. So with retrospective, it's mainly like you find the common characteristic and then you look back to see what the cause might have been. Prospective or longitudinal, also called cohort studies. This is more the future. Okay, so with this, data is collected in data are collected in the future from groups sharing common factors, and that's called your cohorts. And I think the best example I can think of with this is the 9/11 emergency workers, because on 9/11 a lot of the emergency workers rushed in to the towers and they really didn't know what the long-term effects would be. So they took those people that went in at that time and they followed them going forward from that point in time. And that's the prospective or longitudinal study that we see with that. Okay, a couple other definitions just to kind of wrap up chapter 1. Confounding occurs in an experiment when the experimenter is not able to distinguish between the effects of different factors. Okay, so we want our experiment to be able to explain what's happening, and sometimes when you have a lot of confounding variables, we end up with things that you really can't identify what's the actual cause. So an example of that might be if researchers are trying to study the effects of weight gain and lack of exercise, but we also know that a lot of other things might affect weight gain. For instance, your diet, your age, your gender, different things of that nature, your overall health might affect that as well. So a researcher would need to control for all these other factors that might be impacting somebody's weight gain besides just lack of exercise. So that would be called confounding. Okay, when we control for the effects of the variables, we can do that through a couple different ways. We can do completely randomized experimental groups. So we have like different treatment groups and we just randomly assign to each of those, one, to the treatment and to the placebo group and so forth with that. We can do randomized block design. That's is a group of subjects that are similar, but blocks differ in ways that might affect the outcome of the experiment. So maybe with this, you might have blocks with like males and females and so forth with that. The matched pairs design is when you create two treatment groups by using subjects matched in pairs that are somehow related or have similar characteristics. For instance, maybe each group has a 21-year-old female and has a 40-year-old male and so forth. But the groups are very similar, are created in a very similar way. That would be examples of matched pairs. In rigorously controlled design, you want to carefully assign subjects to different treatment groups so that those given each treatment are similar in ways that are important to the experiment. Okay, so this is just a diagram here talking about the matched pairs design. So basically you've got car 1 and car 2 and you're testing gasolines A and B. So both gasoline A and B would be given to car 1, obviously two different times, but still it would be both would be tested on car 1 and here both would be tested on car 2 and so forth. Okay, you can have different types of sampling. So no matter how well you plan and execute the sample collection process, there can be some errors in the result. The first one, your sampling error, basically, or random sampling error, is occurs when the sample has been selected with a random method, but there's still a discrepancy between the sample result and the population result. So this is basically saying you've done everything correct in doing your statistical work and gathering your samples and so forth, but there's still a discrepancy. And we know that things happen by chance. So these are just those chance sample fluctuations. Maybe for some reason your sample, even though you followed everything and did everything correctly, it still was in some way skewed. We talked about like it's possible if you're selecting, 200 that the majority of them are males if you're doing it as a truly random sample, and that could affect your outcome. So you expect it to be fairly representative, but it may not always end up being that way. So that's the sampling error. You've done everything right, but you do still end up with some type of error with your results. Okay, non-sampling error, that's when you do the things that you really can control. That's the human error ones. that maybe you have somebody that enters the data wrong, computes something wrong. Your questions have biased wording. False data is provided. Maybe people self-report. You form biased conclusions, or any of these kind of things would account for non-sampling error. And then the last one, non-random sampling error, is basically when you gather your sample in a way that's not a random sample. That might be your convenient sampling or your voluntary response sample. So you're going to have an error that's introduced because of that, and that would be called non-random sampling error. Okay. All right, so that takes us to the end of chapter 1.